Hello, everyone. Welcome to today's Nlyte webinar titled Managing Your Hybrid Computing Infrastructure, from BMS to DCIM to virtuals to workloads. My name is Mark Gaydos. I'm Chief Marketing Officer here at Nlyte Software. We'll also be joined by Enzo Greco, who's our Chief Strategy Officer. We appreciate the time you're going to be spending with us today. We tend to keep a pretty fast webinar, so we're going to move through this content. If you have any questions during this webinar, please feel free to submit them, and we will try to get to them during the presentation. So without further ado, we'll start engaging with the slides. So let me first give you a quick introduction to Nlyte. Nlyte is a dedicated software company that's been in business for approximately 15 years. We have over 350 global customers here. This is just a partial list of some of the companies who use our technology. As you can see, they come from a wide variety of industries, from high tech to financial services, telecom, government. But what they all have in common is they use Nlyte to help manage the assets that really impact their infrastructure and their workloads. We're on the 10th generation of our technology. We support small companies to hyperscale organizations, from as small as 25 racks to as large as 150,000 racks. We pride ourselves on being very easy to do business with. We've got global partners such as BMS and HP and IBM who we work with. And we pride ourselves also on providing a complete solution for all of an organization's workload asset infrastructure needs. And the last thing, we are dedicated to the success of our customers. And as a result, we have a 98% customer retention rate. And we are focused on making sure we provide our customers value and we keep them satisfied. So our mission is what we refer to as workload asset management. We are focused on helping companies manage a hybrid world, a very complex world of the infrastructure architectures that are out there, to help them deliver positive outcomes for their workloads. Because in the end, that's what the infrastructure is there for. Organizations don't have data center or colocation facilities or edge facilities just for that purpose. They are there to provide support to the applications. And so that is what we are focused on, is helping companies manage the workload assets that they have and enable them to optimize that through intelligent and insightful and comprehensive management of those underlying assets, from the software down to the facilities. And at this time, let me introduce Enzo Greco, our Chief Strategy Officer.
Mark, thank you very much for that opening, and certainly my thanks to all on the call for your time and attention. And Mark already introduced workload asset management, and it's a very interesting term. And we've always done, as an industry, workload asset management. If we think of managing a data center facility, the reason that we build and manage that facility was certainly not for the sake of the facility itself, but to enable workloads to run. When we install and manage operating systems and system software, it wasn't for the sake of that system software, but rather to allow workloads to run on top of it. And what we have done is cohesively categorize all of those assets in a facility, from the facility itself, the critical infrastructure, up through IT equipment to the software which runs on that IT equipment. All of those assets exist solely for the purpose of allowing workloads to run most optimally. If we look at one of the biggest trends in the industry, namely colocation and cloud, again, the reason that those facilities and options exist are to run our workloads optimally, to allow our workloads to have flexibility in where they run. So that is the concept of workload asset management, which is very concrete because we've always done a form of it. And on this slide, we see all the different aspects that go into properly managing those assets that allow those workloads to run, from the physical assets themselves to the human aspects, how we implement the different systems, how we implement the different workflows, the different procedures that we have, to, of course, all of the digital assets, which include the software and the licensing and all the other necessary components that are required. Once we have all of those different elements, all of those different vectors, we then manage them, we monitor them, we automate, and increasingly we optimize, we apply analytics to it, and then we report on how well everything is running. So workload asset management is this function that, again, manages and optimizes all of the infrastructure that allows the workloads themselves to run, whether on-site or in a much more virtual environment. And to allow management of those assets, there are several features or several functions required. In fact, on this slide, I don't want to focus on the individual products, but rather on the functions that they require, on the functions, that they provide, because what we have done is, I believe we have packaged together very well the key elements that are required in managing your assets to allow the workloads to run. Everything from optimizing the assets to certainly optimizing the energy that you have within your data center, looking within the IT equipment, and then managing all of the technology assets that you have, from the individual devices to the software placement to the software licensing. And given the scale and complexity of many of our installations, it's really hard to manage at scale without machine learning, without some kind of AI and analytics applied to it. So what we have done is we have holistically applied machine learning across the entire stack, from critical infrastructure all the way up to the software asset management. So these are, from our experience and best practices, the key functional areas to properly implement workload asset management. Now, if we go beyond the specific, I think it's very helpful to look at some of the macro trends that are going on in our market. So if we look at the DCIM and the facility market, I think we all see these different trends in different ways, but these are certainly the more dominant. So if we look at growth of edge, certainly we see, and all the analysts have written, there were numerous articles about the growth of edge, but this is all about putting computing and data where it can be used best, putting it as close to the users, increase resiliency, decrease latency. That is the whole purpose of growth of edge. But what is important about edge is that first of all, these much smaller facilities, if you will, are not standalone. They are part of a much larger fabric. So we cannot view an edge facility as being a standalone facility, build it and forget about it. Rather, it needs to be incorporated as part of the larger computing fabric that we have. Second, almost by definition, many of these edge facilities are going to be dark. They're going to be remote. We don't have the luxury of walking the halls, of walking the space and finding out what a problem is, finding out what capacity we have, finding out the state of the facility. So we will need ever greater intelligence, and in some cases, ever greater extreme automation to bring edge to life. Second, we look at the colocation market, and there are many large players in this market: Equinix, Digital Realty, Data4, to name a few. And there is increasing competition in this market, and what we are seeing is these colocation providers necessarily needing to differentiate their offerings. It's a very competitive market, and in some ways it's a commoditized market, and that differentiation is becoming ever more important. Next, we'll touch a little bit more on this later, but enterprise data centers now have what's called optionality. It is very easy to consider options from a variety of players, whether it's colo, whether it's software as a service, whether it's consolidation. And what is happening is these enterprise data centers need to be ever more efficient. They need to be competitive with the options in the marketplace. The next is we need to holistically view capacity and management. We can't view our facility distinct from our IT and from our applications, and vice versa. As we deploy a new application, the facility should pick up that kind of change and be able to tailor itself accordingly. And again, we'll have some interesting examples on that later. And then finally, if we look within our ecosystem, there's ever more options. If we look at something as usually or traditionally as simple as cooling, rarely do we build a facility now with just room level cooling. We often have precision cooling, often down to the rack level. So if you think of certainly the massive amount of control that we have, but look at the massive amount of complexity that we have introduced in optimizing and managing that facility. So what is happening there is a requirement for deep integration from the critical facilities themselves up to IT, up to, of course, the workloads themselves, because that's how we will get the best use of all of those facilities and all of those systems. So these are the key macro trends we see in the market.
Hey, Enzo, we've got a few questions that have come in.
Okay.
One, and we might as well just take them as they come in. One of the questions was from Peter. How are co-locations differentiating themselves? I think you'd referenced that during the slide.
One of the key ways is, well, first look at what a co-location provider is providing. They are primarily providing space and they are providing power and communications. So how do you differentiate in that market? What the different co-location providers are doing are providing, for example, remote visibility. It's still your equipment, it's just living someplace else. So it would be very advantageous to be able to see that equipment, at least on a screen. So remote visualization, in some cases remote management. In many cases, providing a portal so that the end users can validate their SLAs so that remotely they can see the state of power, the state of thermal. They can see where their equipment is living to make sure that it is in an optimal state. So it's this value added that is being invested in by all the colo providers for two reasons. One is to provide differentiation, which they need to do in an increasingly commoditized market. And second, to provide additional revenue.
Okay, great. Thanks.
All right. So if we then go on to, so we've already mentioned in workload asset management, it spans the entire environment, the entire ecosystem, from the facility itself up to data center and infrastructure management, up to virtual management, up to the workloads. Why are we seeing this end-to-end integration becoming such a requirement? There's a couple of key things. First, and we've already mentioned a little bit of this, the need for complete and accurate holistic capacity management. And there are some key issues that are driving this. I'll just mention a few. Scheduled maintenance. If I'm going to do critical facility maintenance, shouldn't my applications be aware of that? So if I'm going to shut down my UPSs, for example, for maintenance, for battery maintenance, shouldn't I automatically alert my workloads that are running within that environment so that perhaps they can be migrated elsewhere? If I'm going to do application maintenance and suddenly I'm going to take SAP down for major maintenance, why do I need to keep my facility running at full tilt? I don't. So that is one good example. Another good example is, again, if we look at the workloads, it's all about where those workloads are running. And certainly it costs different. There are different characteristics, whether I run a workload on-premise in a traditional data center, whether I run it in the cloud, whether I run it in colo, or whether I run it as a service. So there are now new metrics that are starting to be introduced, such as cost per workload. And the only way to calculate those accurately is to have a end-to-end view of all of my systems. So that's one big driving factor. Another is we all deal with failure and recovery, and often we get failure and recovery scenarios that are disjointed. Our software fails and it doesn't flow through to the critical infrastructure. More importantly, my critical infrastructure may fail and I may get warnings from that, and I often don't filter that up into the virtual management or ultimately into the workloads themselves. To increase that resiliency and to better all of these scenarios, having that automated and integrated failure and recovery scenarios, we're seeing a very large trend towards that. And then the last one that I'll just mention on this slide is the end-to-end alarm and alert management. There are an awful lot of things in our data centers that raise alarms and alerts. And often they are conflicting, often they're not integrated, often one alarm is not correlated with another. And that's hard enough to manage. If we then look at the rise of edge, this becomes even more hard. This becomes even harder to manage because we don't have the ability to be on site to really understand what's happening and understand what the fault is. So we need to have this intelligent, autonomous, integrated alarm and alert management. Because of the complexity of our computing fabric, this is becoming ever more important. I think we all have a realization of that.
So Enzo, again, we've had more questions come in. I thought I'd take one on. I think it goes to the beginning of this slide, which comes in from Nicholas, who asks, in most situations, do BMS and DCIM overlap or coexist?
I'll take that one. So it depends, but often you will find BMS in almost all facilities of some kind. And you will often find DCIM, particularly in data center facilities. Traditionally, these systems have been quite distinct. In fact, sometimes even managed by two different teams. But because of all the trends and some of the specific factors on this slide, we are finding an ever greater requirement for those to be integrated.
Okay, thanks.
On the next slide, we've already mentioned cloud several times, and there's an interesting aspect to cloud, which is it is simply an option. It is a powerful option, but it is an option. I think there is maybe a view by some that the cloud is the answer to everything, and certainly it's not a panacea. There are many valuable aspects to cloud, but what we are finding, what I think we're all seeing in the market, is the ultimate state of our computing infrastructure is going to very much be hybrid. We will have our enterprise data centers, we will have cloud, we will have colocation, we will have Office 365, and these are all options, these are all part of the fabric. And cloud is important, but it's not the only option. So when we look at this, and we mentioned before that enterprise data centers need to compete with alternatives, this is why, and these are some of the alternatives. But again, they are alternatives. And increasingly, enterprise data centers will be measured more carefully. They will be under greater scrutiny, which is not a bad thing, but they will be weighed against other options that organizations now have. So what we're seeing is much better metrics and much better measurement in data centers around availability, security, and costs. And to do this, at least to have some metrics for decision-making, some metrics for benchmarking, we are seeing the rise of the kinds of reporting and how to measure optimization so that we can measure our enterprise data centers against alternatives. And in the United States federal government, there has been a concerted focus on this for the last many years called the Data Center Optimization Initiative, which is a formal and standardized way of measuring data centers from many different aspects. And one of the outputs of DCOI is to determine not just the viability, but the management, and are data centers the right alternative compared to others such as cloud. So cloud, again, a very important part of all of the different options which we now have.
And I'm going to jump in here, Enzo. Again, we have another question, this one from Barry, and maybe you covered this, but maybe we can talk a little bit more. The question is, can enterprise data centers actually hope to compete with cloud services and as-a-service models, question mark?
I will certainly add, this is something, Mark, that you and I have spoken about in the past. I know that you have some strong views on this. I'll just add a few. One is, absolutely. There are several distinct advantages which enterprise data centers have. Certainly they have a different type of security, but they also have manageability. You have the ability to walk the aisles. You have the ability to place equipment. You have the ability to prototype. There is a very large aspect in data centers that I think we all have experience with, where we have staging areas. We have testing areas before we put equipment and applications into final deployment. It's really hard to do that in a
and I would jump in and I would say, I mean, ultimately the world is going to be a hybrid world, and so I think cloud is certainly going to play part of the strategy. But I think in the end, as we've discussed during this webinar, the focus is on the workload, on the applications, and the cloud may not be the best scenario for certain applications, or the cost might become prohibitive to run it in a public cloud. Having done it formerly at a platform as a service company prior to this, many organizations reached a certain size for particular types of applications and moved out of the public cloud back into either their own data centers or colocation facilities because it became brutally expensive. Or they'll do a combination. They'll have resources such as the compute running, for instance, at an AWS, while they'll actually have the database running in an Equinix facility. So you're starting to see those types of hybrid environments. And so certainly the business model is going to matter, the compliance, the security, and the performance is going to ultimately be important in determining whether you're going to use public cloud. So I think data centers aren't going to be going away, but I think cloud is going to play a greater role for a lot of organizations as part of their strategy.
Agreed. And the last thing that I would add on this discussion is it's a really interesting dynamic that's happening in the industry. The industry is still trying to determine what are the right metrics for where my workload should run. So it's not purely on cost, and even just on cost, it's hard to determine all of these options. So as an industry, we're still trying to determine, of all the options that we now have, what's the right way to measure them, and what's the right way to optimize all of the infrastructure that we have. Thanks for that input, Mark. So on the next slide, we then go back to one of the comments that we had at the beginning, which is, if we look at the scale, complexity, and optimization that these data centers require, it is simply impossible to optimize those facilities or optimize that infrastructure without something like AI, without something like machine learning. There are simply too many inputs and too many possible outcomes. And Gartner, several months ago, published a report, a viewpoint, where they believe that within a few years, a good percentage of data centers that don't implement AI and machine learning won't be optimal, won't be optimized, their operations won't be sufficient to keep them economically viable. And whether it's 2020 or whether it's 2022, at some point in the not far off future, I think we all have a sense of this. So this is quite significant. So today, where are customers implementing analytics? There's a couple of key areas. There's always going to be preventative maintenance and failure prediction. And on the next slide, we'll talk about this in just a little bit more, because analytics provides just a whole different aperture into the kinds of maintenance and prediction that we can perform. But then there's also anomalies. If we look at, for example, is there a correlation between who was in the building and certain security or performance events in our facility? So perhaps whenever someone is in the building, there is a great correlation for historic security anomalies. It's that kind of analysis that analytics and machine learning open to us. And then finally, there's always facility optimization. And this is going to be optimizing the power, optimizing thermal. This is going to be optimizing availability, which is always going to be paramount. It's going to be optimizing the facility using data points that we never had available to us before. And this is what Gartner was getting at. When some of these facilities, especially the newer, the larger, the colocation type facilities, when they start implementing AI at this scale, they will have different economies, and they will have, in fact, different economics that may price out other alternatives in the marketplace. So on the next slide, we're actually going to look at this in just a little bit more detail.
Hey, Enzo,
so
I'm sorry. I just want to jump in here. We got a question from Kumar, and the question is, what sort of things should someone wanting to adopt AI in their facility watch out for?
I would say two things. The first is make sure that you are automating or analyzing the appropriate function. And the second is, what's your tolerance for control? So for the first one, there are many functions that we can do in our data center. There are many functions that we have in our data center. Not all of them are equally amenable to applying analytics to. And it becomes important to focus our analytics efforts on the areas that can benefit most. However, from experience, we can share that some of the areas that can benefit most are some of the harder and more involved areas, such as workload management. So it often becomes helpful to start with analytics in a much more defined area. For example, it could be thermal control. It can be predictive power. So it is important analytics is definitely a learning system. And it becomes important to implement it so that you start collecting data, so you start working with it, and start simple, but have a vision for where analytics can be applied in your environment. That's the first. The second is, what do you have comfort in providing control to your AI system? So for example, if your AI system comes back and says, the optimal set point for your air conditioner, for your chiller, should be 2 degrees or higher. Do you have comfort in having the AI system automatically control that? Or would you prefer to have the AI system send you an alert saying you should increase your set point by 2 degrees? Different organizations will be quite different. And thermal is quite easy, because whether you set your set point automatically via AI programmatically, or whether you get an alert and then set it manually, that's not nearly as critical as, for example, workload management. If your AI system comes back and says in near real time, you should move this workload because you have an impending failure in your critical facility, you probably don't have the luxury of having human intervention at that point. So that becomes, what is your tolerance for control? And what we're seeing happening in the market throughout the AI market, think of self-driving cars, this is certainly an evolution. There certainly is an evolutionary aspect to it. And as more and more organizations become comfortable with this, this will become de facto. There was a real interesting story that Google published just a few weeks ago that said they now use self-controlled AI within many of their data centers to manage the thermal, to manage the environmentals within that facility, and they are finding 30% energy savings accordingly. So essentially, they have given over control to an AI system. That's an exceptional level of control, which perhaps many of us can aspire to. But that is, I think, a great vision that Google has set. So then going on to the last major slide. So if we look at analytics again, one of the most interesting things about analytics in the context of a data center is a data center generates a tremendous amount of data. We generate data from the critical facility. Think of all the power and thermal information that we generate from our generators, from our batteries, from our chillers. We generate environmental. Just think of all temperature and humidity sensors. We generate a tremendous amount of data from our servers, especially if you have a facility with 40,000 servers. Just think of how many data points you're generating. We have data from the applications. We have data from the operating systems. We have data from our security systems. We have data from all the user information that we gather. And all of these data points can be important. Typically, we ignore most of them. And what analytics provides is, and this is the whole area of multivariate, is now we can apply a very, very rich set of inputs to achieve ultimate outcomes. Typically, we had very specific KPIs or metrics like PUE. And to do PUE, we had a very specific set of inputs. And that's all that we looked at. What were we missing? So what analytics provides is the ability to take a very large set of inputs, find those hidden patterns, find those hidden gems inside of the data which we already have that allow us to have far better outcomes. And this is absolutely the state of the art. And I think as we go forward, this will become ever much more so the norm in which we operate and view our facility. So there are a couple of areas where there significant investment is being made in this multivariate analytics. Certainly advanced preventative maintenance. The more different kinds of inputs that we get, we will be able to better predict failure. We will be able to perform better maintenance on our facility. We will certainly have ever more optimized facility. If we know, for example, how our applications work, if our applications are really quiet on a Saturday afternoon, why do we have the complete facility running as it does on a Monday morning? You probably shouldn't have that. Being able to predict that will make our facility, our applications, how we manage everything that much more optimized. And then we already mentioned this lightly before, but this is really becoming a major focus in organizations, is picking up security anomalies by looking at all different kinds of data. Don't just look at application data, for example. If perhaps there's a correlation between a security breach and the people in the facility, as we mentioned before, that may be one strong correlation, but there may be others that we haven't considered. So with that, having a full set of inputs that we can then apply analytics to will help us to better detect security anomalies. You probably have seen from the different AI vendors, be it IBM or Google or others, security anomaly detection is a key area. And what we are seeing is that being applied very specifically to data centers. So then for going forward, a few points here. If we look at what we just spoke about and some of the trends in the industry, some recommendations, some firsthand best practices. Perhaps you're already doing a certain degree of this, but you must take a holistic view of facilities and applications. These are not distinct areas. They are, I know that traditionally they have been viewed as quite distinctly, but for all the reasons we've gone through in this presentation, they simply are not distinct. There is a concept of data center aware workloads. Workloads should behave differently based on where they're running and the characteristics of that infrastructure. Facilities should also behave differently based on application behavior, and we gave some examples of that. It becomes important to consider where can analytics in your environment provide unique insight or additional insight. And again, there's this maxim, I will absolutely repeat it again, rich inputs deliver optimal outcomes. And if we look at the scale and complexity of a modern data center, there are numerous possible outcomes, numerous possible paths. It simply becomes impossible to manage those manually, and that is a great role for AI. And if we look at what analytics really provides, is it allows our facility, our operations, our applications to shift from reactive to proactive. Nearly everything we do in a data center is reactive. Our chillers turn on based on thermostats, which is current. Our applications react to a particular failure. We shut certain entry points based on current security breaches. So that's all reactive. What analytics allows us to do is shift that to become proactive. The next, and there's many reasons for this one, is consider and define benchmarks beyond PUE. As we said before, if we look at the optionality that we have in our industry, enterprise data centers, cloud, software as a service, colocation, each of these are options. And it becomes important to use them in the right way and use them in the optimal way. And we need to have the right measurements and the right metrics, both to measure our facility and to evaluate the different options. And then finally, incorporate cloud and edge. Mark already said this before, but cloud is an important option, but it's just that. It is an option, a valuable option, powerful option, but it is an option in our larger and overall computing fabric. So incorporate cloud, incorporate edge, incorporate the different facilities, the different options that we now have into your overall approach. So these are some very strong recommendations that we find firsthand organizations are taking advantage of. And finally, a few resources. So these are both specific to our product set. These are industry resources. These are views that may be of particular interest and benefit to yourselves, focused on the key areas that we spoke of. Data center infrastructure management, which you probably are familiar with to different degrees. Technology asset management, which again is how we view, manage, collect all of information about all of the different assets from software to devices that are required to run the workloads. And then the whole AI, analytics, machine learning, that adds a very different perspective to all of the different functions that we find in our environment. So these are different areas that may be of particular interest and benefit to each of you.
Yeah, and for everyone out there, I'd also like to point out, if you go to Nlyte and click on our resources page, there's actually quite a bit of information that's not related to specifically our products. There are customers ranging from Cisco to Northwest Mutual to Verizon to NASA, of organizations talking about the challenges they face as they manage their computing infrastructure and the types of ways they approach those problems. We've gotten a lot of questions which are sort of specific to those organizations about specific products they have, whether it's integrating BMS with DCIM or other particular questions that seem very specific to those organizations. I would like to end on one question which came from Eric, and the question is, Do you think there is a potential for machines to take over many of the jobs carried out by humans in the future? Are certain vocations under threat? It's sort of a macro question. I thought we'd end with sort of that macro type question. Enzo, what do you think?
Not in the context of the data center. I think that data centers are already well automated. They already run in many cases on very sparse teams. I don't think that vocations in the data center are under threat. I think what machine learning will do is two things. For existing functions, it will provide ever better insight and better outcomes. Think of, again, thermal management. That's a great example. The second is machine learning will open up new areas of insight. So, for example, workload management, security anomaly. So I think that is where machine learning certainly will have an impact, but in the context of a data center, I don't think it threatens any particular roles or vocations.
Yeah, I think ultimately the gist is that it'll be helping people do their jobs. It's not going to be replacing. I think people are going to have more insight from machine learning. It's not necessarily going to be replacing jobs or replacing responsibilities. I just think it's going to allow people to do more in less time. So thank you for that last question. And I'd like to thank everybody who participated in this webinar. We appreciate you taking the time. We look forward to seeing you on future webinars. Thank you.
Thank you.